In this video, I'll cover some of the more unusual cases about finding all the subnet IDs of a network. More unusual in terms of what you might encounter on the test. Just so you've seen it, I'm less worried about whether you can do this on your own. So sit back, relax, soak this in, and learn a little bit, and then go back and practice with those earlier videos. All right, let's do it. Now this intro is a little bit different than most, so pay close attention here. As usual, the book has the same content. It's found in Volume 1, Part 4, Chapter 15 in the current edition. It's the last section there. That chapter has a section on choosing masks and then finding all the subnet IDs once you've chosen that mask. And this video is one of 4. I took that one section from the book and made 4 related videos to chunk it up into videos about progressively more complex parts of the process. Here we are at the most complex part of the process. So what have I done for this particular process, this part of the process? Well, we've taken the cases where there's lots and lots of subnets. If it's more than 8 subnet bits, it means more than 256 subnets. So we'll start by getting some perspective on what's that look like in a Class A network, then in a Class B network. It's impossible in a Class C network, by the way. And then I'll give you 2 examples in a Class A network and 1 example in a Class B network, just so you can see how this expanded process will work. So it's an expanded process. I assume you know the base process. So in the 3 earlier videos, I went through the process repeatedly and showed you examples. I assume you have that down. So here's what you should be thinking about that earlier process. You've seen the videos, you understood the first simple one, you got the second simple one, you understood the third simple one with less than 8 subnet bits, and you practiced it, and that's where you are now, because I'm going to expand upon it. If that's not you, then you're not ready to get going on this video. Hit pause, go back and get into those other ones first. But if you've done all that, let's go. All right? As always, stick around to the end, and I'll give you some advice of where to focus after you get through this video. Consider, if you will, for a moment, Class A networks, and you're going to subnet them, but before you subnet it, if you're thinking about a Class A network with its default mask, there are no subnet bits and there are no subnets. So the default mask is /8 because we're subnetting a Class A network. There are 8 network bits, there are 24 host bits, no subnet bits, no subnets. So then you choose to subnet the network, and you choose 1 mask and 1 mask only. So we can do this kind of math. And say you chose a mask of /20, giving you 12 subnet and 12 host bits. All right. So you've got 2 to the 12th subnets created by such a choice, or 2 to the 12th being 4096, 4096 subnets created. So that's the size of number of subnets I'm talking about in this case of more than 8 subnet bits. Anything that gives us more than 256 subnets. Like this choice, if instead of /20, you had chosen the ever familiar /24 mask, 16 subnet bits, that's 65,536 subnets, or maybe even a /28, 20 subnet bits, over 1 million subnets. So you can imagine asking test questions saying things like find all subnet IDs with this mask in a Class A network. It can be a little problematic to craft a question that points you to one answer, right? So for that reason, I think they're less likely to be seen on the test. That's just Wendell's personal opinion. But it doesn't hurt to understand the problem and apply our process to finding all subnets of a network, even though there are going to be tens of thousands or even millions of subnets created. You can see the pattern and figure out how to describe what those are. All right. So that's what this video is about. So again, consider, if you will, what are some of the masks that would do that for a Class A network? Here's our default mask for Class A. Well, a /17 would give us 9 subnet bits, a /18 would give us 10 subnet bits, and so on. And then we see the number of subnets created by those. Those are some examples of masks in the context of what I'm talking about having to expand our process to find all subnet IDs. Now, if we start thinking about our process with this kind of expansion, let's think about, say, a mask of /24 with a Class A network. Well, if we think about our classful analysis, we've got 8 network bits because we're subnetting a Class A network. With a /24 mask, All 8 bits in the 4th octet are host bits, but the 16 bits in the 2nd and 3rd octets combined are subnet bits. So the 2nd and 3rd octet are going to be subnet octets. So we're going to have to expand our thinking and what our process tells us to do in terms of having 2 separate subnet octets. So that's what I'll talk through with you in the 3 examples. But first, let's talk about these same ideas in the context of Class B networks. For Class B networks, it's a similar idea, but Class B, the default mask is /16. So before you subnet a Class B network, you've got this mask, you don't have any subnet bits, so you've created no subnets. But if you were to choose one mask only to subnet the network, and you chose a /26, you'd end up with 10 subnet bits and 6 host bits. So 2 to the 10th is 1,024, you would have created 1,024 subnets. Or if you had chosen a /28, 12 subnet bits, 2 to the 12th subnets, or a /30, 14 subnet bits, 2 to the 14th subnets, and so on. All right, so that's the context in which I'm talking about more than 8 subnet bits in a Class B network, for example. And if I just look at it in table form, there's our default mask with no subnet bits. Well, you've got to get up to a /25 before you get up to 9 subnet bits. That is more than 8 subnet bits to get up to 512 subnets. So /25 all the way up through /30, which gets us up to that 16,000 and change number of subnets. So we're going to expand our process with these next 3 examples to show how could you find all the subnet IDs in these cases. Clearly, we're not going to write them all down on a piece of scratch paper, right? We're talking about thousands upon thousands of subnet IDs, but you can see the patterns and figure out, well, what would they be if we took the time and effort to write them down? By the way, when you are thinking about buying my books, any other books, or anything else for that matter, if you'll start with this QR code or my link tree and buy from there, you don't have to pay anything more, but those sellers will give me a small affiliate marketing credit. It's a great way to say thanks and support the channel. All right, let's get back to the content. So here's a revised written version of the process to accommodate the fact that we've got multiple subnet octets, but I'm not going to teach from this written version. It's here for your reference. I'm going to instead show you the example. So let's do the easy parts first. And the network and host octets, we're still just going to copy. All right, going to copy the network ID, copy the host octet. It's those 2 subnet octets for which, get this, on the one on the right, we're going to treat it just like we always did, add the magic number. The one on the left, we're going to count from 0 through 255 by ones, always. All right? Subnet octet on the right, we're going to count by the magic number. Subnet octet on the left, we're going to go 0 through 255 by ones, treating this as a block. So stay tuned while I show you how that works. So classful analysis is Class A network, 8 network bits, 1 network octet. That part stays the same for every subnet ID. 1 host octet, that part stays the same as 0 for every subnet ID. These change, these middle 2 octets, all right, by our classful analysis. So here you go. You write down network 10 as the first subnet, the 0 subnet. You copy the 10s, you copy the 0s in the 1st and 4th octets. Then you got to figure out what to do in here. So what you're going to start with then is create 1 block, that's my word, 1 block of subnet IDs with 0s in the left of the 2 subnet octets and counting by magic number in the one on the right. So count by the magic number in the one on the right. So what is the magic number in this case? Well, it's 256 minus 255, or 1. So add 1, add 1, add 1, add 1, add 1 up to here while holding a 0 in the left subnet octet. And you've created a block. It's our first block of subnet IDs. Now I stopped at this one that has a 255 in it for similar reasons to our old process, right? If you added a 1, you'd get to 256. That'd be out of range. So that tells us we're at the end of the block, but not at the end of the list of the subnets. It's not the last subnet. It's just the end of the block. Then our expanded rules tell us that we want another block that goes 0, 1, 2, 3, 4 to 255, but with ones over here. And then we're going to want another block with twos over here and another block with threes over here. In fact, it doesn't really fit well on this style of slide, so just to cram it in there, here's a block with zeros in the leftmost octet, counting 0 through 255, and here's some with ones in the leftmost subnet octet and twos all the way up to 254s and 255s. All right, so that's the pattern. So you can practice a process to where you can say, well, I can figure out the pattern. Obviously, I don't want to write down 65,536 subnet IDs, but I can figure out the pattern and even predict what the last few subnet IDs are if that is useful to you. So there's an example of how to do the process. So just to show it visually, in any network octets, I'm going to copy those down. Host octets, I'm going to write zeros. In the rightmost subnet octet, in this case, because the magic number was 1, I'm counting by ones. And in the leftmost subnet octet, I'm always going from 0 to 255 by ones. No consideration of a magic number there. And basically, I'm finding every combination of those two to create my complete list of 65K plus subnet IDs. Let's again do a Class A network, but this time with the /20 mask. So visual rules. For the network octet, we're just going to copy the network ID value. For the host octet, we're always going to copy, and it's going to be a 0. And then in the two subnet octets, the one on the right, that's where we keep adding the magic number, like usual. And then on the left-hand one, that's where we have a 0 for the first block, a 1 for the second block, a 2 for the third block, and so on, all the way up through 255 for the last block. All right, so it's the same process, but this time with a Class A with a /20 mask, it turns out all the second octet are subnet bits, and the first 4 of the third octet are subnet bits. But for our process, as always, if at least one bit in the octet is a subnet bit, we'll treat it as a, quote, subnet octet for Wendell's process, all right? So we've got a rightmost host octet, and the middle 2 octets are subnet octets for the process. So when we set up our problem space, we leave 2 octets wide of space for the subnet octets. We copy the network ID value for the network octet. We write down zeros for the host octet. Here's where our interesting work happens there in the middle 2 octets. So we want to create our first block, right? And we're going to have zeros in the left subnet octet in our first block. And we're going to count by the magic number in the rightmost subnet octet. So what's the magic number? Well, we take 256 and we take 240. Why 240? Well, we're working in the third octet, so we take the mask's value in the third octet, subtract it from 256 to get 16. So that's our magic number here in the third octet. So we add 16, add 16, add 16, add 16, all the way up to 240, and that's the end of our block. I know that's the end of the block because if I added 16 more, I'd get to 256. That number is out of range. So it's the same kind of logic to see that you're out of range, but it's not the last subnet ID, it's the last subnet ID in this block. All of these subnet IDs have 0 in that leftmost subnet octet. So there's a block, and then we need another block with ones, another block with twos. So here's our block with ones, and then imagine another block with all twos over here, and threes and fours all the way up through 255. So visually speaking, what's the pattern? It's a 10 in the network octet, a 0 in the host octet, 0 through 240 by 16s in that rightmost subnet octet, and 0 through 255 by ones in the leftmost subnet octet. And it's every combination of those to find all of the subnet IDs. For this third example, with the Class B network, with a mask that makes the third and fourth octets subnet octets, we won't have any host octets. We'll have 2 network octets where we just copy the network ID. And we'll take that same approach in the 2 subnet octets where we count by the magic number in the rightmost of those, and we create blocks with a value of 0 through 255 in the leftmost of those subnet octets. So let me walk you through this example. So we're going to subnet network 172.28.0.0 with this dotted decimal mask, which matches /28. With that /28, we end up with a 12-bit subnet field. That means all of the third octet subnet bits and the first half of the fourth octet are subnet bits. So for the purposes of this process, both the third and fourth octets will consider to be subnet octets. They'll change for each successive subnet ID. All right. So our process then says, all right, set up the problem. We've got network octets and subnet octets. And it's that subnet octet on the right for which we'll count by the magic number as calculated for the fourth octet. So what is that magic number? Well, we go to the dotted decimal mask, fourth octet 240, subtract it from 256 to get 16. That's our magic number in the fourth octet. So we're starting with 0, add 16, add 16, add 16, and we get all the way to 240. And we stop there because if we added 16 more, we'd get to 256. That'd be out of range. So that's how we know we're at the end of the block. Now, this first block of subnet IDs, our convention is, with this process, to have zeros in the left of the subnet octets. And then we create another block with a 1, and then another block with a 2 over here, and another block with a 3, all the way through 255. All right, so that's the pattern that I'd want you to recognize. So that, hey, it's just 172.28 on the left, and we're going to go from 0 through 240 by 16s in the right-hand side to create a block, and then we're going to go 0 through 255 by 1s for each successive block to create 256 blocks where we see this pattern repeating. Whew. Congratulations, you made it to the end of the instructional videos related to subnetting in this course. Now, for this particular video, my goal was for you to know this last little bit for real life. It's far less important for the exam, but the earlier videos about finding all subnet IDs, those are very important for the exam, so make sure you've got that down. If you haven't yet taken advantage of the resources in this particular chapter, read the section or practice some of the practice problems there that can be useful to you. We are at the end of the chapter. It's got chapter review, but mostly it's about those skills. But more importantly, we're at the end of the subnetting part of the book, which is a pretty important part. And I highlight that because I'm not releasing it the same day as this video, but probably within a week, I'll have a part review video. And that's a very important part review video because it coaches you through what you should do for the next 4 to 6 weeks, literally, to continue to practice all these subnetting skills, to master them to the level you need to know them for the CCNA exam. So think of it more as your marching orders, your plan to master subnetting for the exam. So watch for that and get into it and practice and be great at subnetting. So where do you go from here? Well, if you really are ready to move on and start thinking about routing, well, click on the left. You'll get to the first instructional video in the next part of the book, which is about router interface IDs. If you're ready to dig in and start figuring out how to practice and review and get great at subnetting, click on that part review video on the right. It'll be on this screen in about a week after I release this video, but look for the part review for the subnetting part of the book, and it'll coach you through how to approach study and practice after you finish learning the basics. Hey, thanks for spending the time. I'll talk to you soon.